Hi folks, thanks to be here for this talk about a backend for frontend. I'm Nicolas Fränkel. I've been a developer for 17 years, a bit more. I went to customers, I worked on projects, I was in several positions, developer, team lead, software architect, solution architects, and then a few years ago I switched to developer advocacy. My usual stack was the JVM, first Java, a lot of Java, then Kotlin. I try to teach me Rust nowadays, but this talk, the demo will be in Python. I'm not a Python expert. I can get by, I can write some stuff, I can read some stuff, so don't expect like amazing code, but probably it will be good enough for my talk. So as I mentioned, I started working like more than 20 years ago, and things at the time were very simple. There were no mobile apps, there was absolutely nothing but computers and the browser. And then the browser made a request to a web app, and then you received data. And that was it. It was absolutely amazingly simple. But even at the time, of course, we wanted to make things more complicated. So a new world was born when people decided, hey, we can have an iPhone. And so there is interesting problem in that case. And the problem goes even like worse when you add tablets to that. Is that depending on the device, be it like the phone, the tablet, or the browser on the use screen, probably you don't want the same data. Of course, you are constrained by your screen size. So it makes no sense to get all the data from like the web app and to discard most of it on the phone, because you don't have like the display size to display every bit of data. So that's called overfetching. And as I mentioned, it's not a great idea, especially since, well, most of us are used to have a big bandwidth, so it's not a big issue, but you must remember that most of the world has like networking issue. Even right now, I have networking issue because I don't have fiber connection. I have a poor ADSL connection, so my upload is very, very slow. Download is okay, but upload is very, very bad. And even I myself consider myself lucky compared to other places. So you cannot decide, hey, I will send everything, and it's up to the mobile phone to filter out, because you will be sending a huge payload, and then like the phone will use only like a small fraction of it. So it's not a great idea. So how do we cope with that? Well, the easiest part is we could have some filters. So for example, we could have like a layer that gets the data, and then depending on the device, we could filter data out. So we can overfetch data on the database. It's not a problem. It's not a performance issue. It might be cost a few milliseconds, whatever, not really an issue. Then we can filter it out, and then we can like return just the data that is adapted to the device size. And it would be nice, right? And we can even like aggregate data, so it doesn't need to be on the same database. We can have like multiple data sources. It's not a problem. But microservices change everything, because what I've just said makes everything more complicated. And I'm French, so I will like take some time to complain a lot. Like, I've watched the industry going down the microservices hype trend. And right now, if you say you are doing monolith, it means you are a bad developer. And if you are doing microservices, you are a good developer. So everybody wants to do microservices because they want to be seen as good developers. Whereas I think that in most cases, it doesn't make any sense to develop microservices. Just to get back to the definition, you can read the definition. It's not my definition, it's Martin Fowler's definition. So if you're not happy with the definition, well, bring it to Martin. I hold no responsibility whatsoever, and well, he's like an authority, so I will defer to him. In that case, the definition is okay. You can check the original article if you want, and it's just a copy-paste. And in the same article, Martin Fowler goes on like listing characteristics of microservices. So in general, if I ask people in like on-site conference, hey, who is doing microservices? I see a lot of hands raised, and people are very proud to say, yeah, I'm doing microservices. Can range from, let's say, like 30 to 60%. So it can be more than half the room. And it's true that if we check all the characteristics, in general, they don't fit all. So for example, the biggest part is the componentization via services. This is like the raison d'etre for the microservices. But as we go down and down, we can see there is a product, not projects. And in that case, a lot of people they lower their hands because they are doing microservices while still handling it like a project, meaning that they have a start date and an end date, whereas a product, you have a start date, but there is no end date. You have a recurring budget that goes from year to year. So if you handle your microservice like a project, then probably you are not doing microservices like they are supposed to be, at least according to Martin Fowler's definition. Now we also have Conway's law. I remember like 10 years ago, when people talked about microservices, they were super keen on mentioning Conway's law. Conway's law is like the law that states that your architecture, your system architecture, will mirror your communication channel inside your company. And so the idea is, if you want microservices, you need to use Conway's law. Like if we say that right now we have a layered architecture, it's probably because we have a layered company organization. So the UI specialist told to the middleware specialist, that middleware specialist talk to the DBAs. And in turn, that gives us a layered architecture. Now, if we want to have microservices, then we must have those teams that are not layered, that are cross-functional, that are autonomous. And in general, the poster child for those autonomous cross-functional teams is the two pizzas team by Amazon, which was popularized by Jeff Bezos, saying, yeah, you must have a team which is small enough to be fed by two pizzas. Of course, it depends on the team, on the size of the pizza. But, well, if your team grows too big, probably it's not a cross-functional team anymore. It's not fit for microservices anymore. And the final nail in the coffin is like whose organization is like this. In general, well, in let's say a room of 100 people, then there is only one or two hands raised. Most organizations are still layered. They are still organized in silos. The reason for that is that you have all those people, and those people have put a picture of, in general, you can recognize them. They have a tie, they have a suit. They are called middle managers. And my idea is not bash middle managers. but let's say that my experience of most middle managers has not been really great. I joked a lot that in general they were meant to like approve my vacation requests, to be the proxy for the raise like each year. And when I mean proxy, it's because you cannot discuss it. They have been handed like the sum and they give it to you. There is no way to negotiate with them, so it's just a proxy, and then they do reporting. Of course, I've had a couple of very, very good managers that really were helping me do my job. So they were trying to remove as many problems from my path as possible. But that's the exception, not the rule. Now, if we go back to how companies are organized, on the left, you can see that here there is probably a middle manager handling the UI specialist team, here as well. But here the problem is it will be very hard to place them somewhere. They actually will find no place or very few places where they can do their stuff. And so the idea of moving from like an organization from the left to an organization on the right is very hard, because the people who can help you do it are the middle managers themselves, because it's about like change management, and actually they are helping making them role completely useless. So it will be in any like legacy organization, it will be very, very hard to do microservices from an organizational point of view. New organization, they can start like on like the organization on the right, and it will be much, much easier. But legacy organization that were like designed like 10 years ago, 20 years ago or more, it will be like completely a big mess. So let's go back to the technical side. Again, I talk a lot about organization. I will talk further about organization. But how can we do the filtering stuff that I've shown just before? So imagine here we are trying to filter, and we are trying to filter in service 1 for the phone and for the browser and for the tablets, and in service 2 we are trying to do that as well, and in service 3 that as well. And if each microservice is the responsibility of one team, well, they don't need to coordinate, but it means that the phone team needs to talk to the service 1 team and the service 2 team and the service 3 team to tell them what they need. And as well for the browser team and the tablet team. And imagine you had a new service, or you had a new device with a different size, or I don't know, now you need to have different technologies with iPhone and Google Androids, then it's going to be a mess. So we are back to an organization mess. It's not possible to filter. Also, probably you don't want to do that, because your phone will need to like make a request to service 1 and a request to service 2 and a request to service 3. So even if you like parallelize the request, it's not a great idea either. So the scope of a single team spans multiple devices, and that's what we don't want. Actually, we need to filter and aggregate for each front end. So each service team needs to understand the logic behind each device. The solution is Backend-For-Frontend. Well, it's in the title of the talk. And the solution is an organizational solution. So the idea is that in front of the services, you have one single additional backend service that is under the responsibility of the device team. So you would have the phone team and the backend-from-frontend phone components. And when the phone team makes changes that require changes on the backend, they also change the backend-for-frontend phone component. And the backend-for-frontend phone component is the one that calls each services, and it does it on the backend side, meaning that it's not an issue to call multiple services, because the network will be much, much faster than if the device would do it. The problem that is in literature, this is what is explained, and it directly translates into a technical solution, meaning that the component here is a dedicated app. And I think that we can go a bit beyond that. So we can actually start to think a bit more. For example, in general, you would have an API gateway in front. And there is no requirement to have a dedicated component. You could have a dedicated plugin under the same responsibility. So for the phone, you would have a phone plugin in the API gateway that does this same like orchestration between the services. So each team would develop the plugin in the API gateway and deploy it independently of any other. There is no requirements to coordinate between multiple teams. So I've talked a lot. Now will be time for a demo. Just as a small slide, I work on the Apache APISIX API gateway. This is the gateway that I will be using in the demo. Of course, it's not necessary to use the same gateway. You can do it with your own gateway. It's just that for me, it's more comfortable. Also, it's an open source solution. It's handled by the Apache Foundation. It's built on Nginx, which is a very solid reverse proxy in the solution. Then you have OpenResty, which is a Lua engine on top of Nginx. Then you have APISIX itself that provides multiple plugins out of the box, so you don't need to create your own plugins. In this case, as you will see, I will need to create my own plugin because there is no other way, there is no generic solution that we can reuse. Hey, let's do it. So here is my application. It's a Flask application. I won't be using a database, but you could do it, SQL, Alchemy, whatever you want. Here I just have the data hard-coded because I'm super lazy. And here I have multiple routes. So I can, as you can see, it's like an e-commerce site. So you can get products, you can get the news, you can have debug information, very important, health endpoint, whatever. And then you have a root that returns everything under a JSON structure. The Docker file is pretty self-explanatory. You just copy the requirements. I'm using the mount cache so that it's easier to build each time. And I just copy the scripts, I expose the port, and I run the Flask, and it's done. Now, as I've mentioned, you should always put an API gateway or a REST proxy in front to protect your API, so you can put cross-cutting concerns such as like authentication, authorization, rate limiting, whatever you want. So here I have my Docker Compose file. I won't be using Kubernetes. I want something simple. I have APISIX and my application. Let's run it. So it should start quite fast because it's a Python application. So basically here it downloads a couple of megs because I didn't run the demo in a long time. Here it's built, here it starts already. We can try to curl to check how it works. Localhost 9080 slash roots, and then we can GQ everything to have nice formatting. So here, that's what I return. I have my debug information, I have some news, and I have the products. So this is a monolith. This was the first step. This is normally what every app starts with. Now we will move to a microservices architecture. So now I have replaced my monolith app with 2 microservices, or let's believe so. So now I have one for the products. I still have debug information, and I have like 2 routes here, and I have the other for the news, again, debug information and the single news that I have. And now I need something to go like across them. And this something is a dedicated Python app, because, well, you are a Python developer, so you probably create your backend for frontend in Python. So I have, again, a Flask app. I get a couple of like configuration parameters for my environment variables, and then I have my routes, and then I make calls to each service in turn, and then I return like my structure. And of course, here I will have like debug information from one service, debug information from the other service. So I need to put it like in a certain way. Here I decide to have all health or information endpoint under the same like info structure, but you can do whatever you want. And let's check how it works. So it has started, and here you can see the structure that I told you about. So you have info, and then beyond it you have catalog and news, and you have the news and the product data. So I changed the structure that I return to the client, but only because I need to make something out of the information endpoints. So I don't have a single one anymore. The application itself is quite easy, the backend for frontend. I just need to point to the gateway route. So basically, the backend for frontend application goes back to the API gateway. The API gateway itself is configured to go to each microservice. So here I have configured the upstream, so I have one for the catalog, one for the news, and one for the backend for frontend. And we see that the routes are for product and catalog. And here, something interesting, I query for catalog/info, and I need to remove the catalog port, otherwise I will forward /catalog/info the product microservice, but product microservice only knows about info, so I need to rewrite it to info. There, you can also use regex if you don't want, but here I decided it was simpler. Same for the news, and here the root is the upstream free. So if I call /product on the API gateway port, I will direct it to the first upstream, which is the catalog. Here I direct it to the news, and the third I direct it to the backend for frontend. It means in this case that I'm also exposing the news and the catalog directly on the backend on the API gateway port, which might not be what you want. It depends on the architecture. Here I made this choice. You can isolate everything and make direct calls, it's up to you. I mentioned previously that in the literature, Backend-For-Frontend is an organizational pattern that is directly translated into a technical pattern. So basically you create your Backend-For-Frontend as a dedicated Python app, and it makes sense because you are Python developers. However, I think it's simplified the stuff too much, and we can do something else. We can actually do the exact same with plugins in place of dedicated Python app. Plugins in the API gateway. So here, that's what I did. I created like a dedicated plugin, and it's the exact same codes that I did in Python before, that how I'm doing in Lua, because in Apache APISIX, either you use out-of-the-box plugins that are in Lua, or you create your own plugin in Lua. Here I created my own plugin in Lua that mimics the code that I did before. Basically, I'm just like getting the data from other components and aggregating them. Here I don't filter. You can do filtering as well, but it's just for the sake of demo. So I created an Apache APISIX plugin. You need to describe a couple of properties: the version, the priority, the name. I also need to describe the schema. Here I don't have no schema because it's not meant to be configurable, because this is very custom. Then I have my fetch data. So here I describe a couple of endpoints that I want to fetch data from, and here I will do them in turn, and everything happens in this function. So here I iterate through these like data endpoints. I fetch the data, I get JSON, I decode it, and this is it. This is exactly again the same code that I did before. I didn't care about too much error handling. I didn't do it in Python either, so it would make the final code a bit more complicated, but not by much. This is where the magic happens. This is how you create a dedicated plugin that has no upstream. By default in Apache APISIX, every plugin is applied to a route. Every route has a dedicated upstream, meaning that you forward the request to somewhere. Here, I don't forward the request to somewhere. I want the request to be handled by Apache APISIX itself. So I need to create this kind of stuff. This is called an API. And you define the methods, the URI, and the handler. Here we can see that I have added the plugin, the new plugin, which is Backend-For-Frontend, the one that I created, and to make it like a regular route that doesn't forward to an upstream, that just handles the stuff itself, you need to add the plugin called public API. Let's see it work. And you have the exact same results. On the client side, you see no difference. It's the same architecture. It's the same data structure. But inside, from the API gateway, of course, the calls are different. It's not the Python app that handles the call. It's the API gateway itself. As a bonus, if you don't want to write your own plugin because you don't want to do Lua or for whatever reason, there is a generic plugin in Apache APISIX, which I would call it a poor man's BFF. So you can make end calls from the Apache APISIX side to different services. And then it returns everything, so there is no aggregation nor any filtering to the client, and you need to do like everything on the client side. So the payload will be too big, probably. This is the overfetching issue that I mentioned, but at least you will make from the client only one single request. So you will make one single request to the API gateway. The API gateway will do all the requests and it will like return everything. So if you don't have time, if you don't write any Lua, you can do it as an easy way, as a poor man backend for frontend. It won't be proper backend for frontend, but it can still be useful without you writing any code. So here are my takeaways for this talk. Please don't do microservices. Microservices are an organizational solution to an organizational issue. And the issue is you have too many developers working on the same code base. It's not a technical solution. Don't think it's about scaling. Actually, if you set up microservices, you will actually decrease your performance a lot, because instead of doing like inside your runtime, making API calls inside your runtime, you will make like network calls. And network calls are longer. Then you will need to decide, okay, now inside an API call, either it succeeds or it fails. By doing a network call, there is a third solution. Then you don't know what happens. Like you sent a request somewhere and you never got any results. You don't know whether the service was actually called or not. So you've got a lot of issues if you want to migrate to a microservices architecture. But getting back to the organizational issue, that's the issue that I want to describe is you have too many developers working on the same code base. That's the only valid case that I know where you would implement microservices. And actually, companies that are advertising for microservices are, in this case, they have many developers working on the same code base. Like the GAFAs or even like huge banks, there are too many developers working on the same code base. Then you would split your code base. Makes sense to do microservices. It opens a huge Pandora box. You will need to cope with lots and lots of technical issues, but that's how you scale your development team, not your technical architecture. You scale your development team by doing microservices. If you are not in this case, please don't do microservices. Really don't do microservices. Last year I did the exact same talk, and I was asked by one of the attendees, hey, can I ask you a question? Yes, you can. Yeah, we have 60 microservices. That's a lot. How many developers do you have? 5. They had 5 developers and 60 microservices. This is completely crazy. This is completely reverse. Even you would have 12 developers, they can work on the same code base. As a couple of years ago, I worked on an Nespresso application that handled like the worldwide website for Nespresso, where you could order your capsules, and it was really a huge site. We scaled up to 70 developers. At 70 developers, we started to feel some issues regarding the branching strategies. There was a dedicated release manager who was like tasked to handle all the branches. That's where actually we could have split the code base, but not in tens of microservices, perhaps only in 2 microservices or macro services. So again, don't do it. But if you do, and you have multiple devices, then Backend-For-Frontend can help you. And again, Backend-For-Frontend is an organizational solution. It's not a technical solution, so you have different implementation. One would be to create your own application. One would be a plugin in the API gateway. Perhaps there are others that I didn't think about. You know the sentence, every problem is a people's problem. I believe that's probably wrong, because you can talk to people, direct people. You cannot talk to organization. Worst case, if you have really problems with people that cannot be solved, you fire the people. It's easy. But organizations, they carry a lot of inertia. You cannot fire them. You need to work with them. It takes a long time. It takes a lot of energy to make any changes, and even more so when you are in a technical role, because, well, you are only technical. So in general, the organization look down upon us because we are technical, right? So be very, very careful. Think about it. If you are a developer, probably you won't need to deal too much with these issues. If you start being an architect, a solution architect, then you will need to deal with the organization a lot. And in general, it will be like more powerful to try to change the organization, although it will be much, much harder than to try to find technical solution to an organizational issue. Thanks for your attention. You can follow me on Twitter. You can also follow me on Mastodon. If you're interested about the codes, then everything is on GitHub. There is a bit.ly link, so I can check whoever checked the code. If nobody is interested in the code, that's also good feedback for me. And if I got you interested in Apache APISIX, though the talk was not about Apache APISIX, well, please have a look. It's an open source API gateway. It's handled by the Apache Foundation. So thanks a lot for your attention and have a good day.